All right, so this is a continuation of lesson 8.3. My apologies for the disruption of the video. Getting back to working with graphing these parent functions. Let's actually take a quadratic real quick that we're going to have, which is the following equation. We're going to take the f of x is equal to 2x squared plus 8x minus 1. I'm not going to worry about factoring this thing yet. What I'm going to try to figure out is the following, is that in this whole thing, I have something that's going to go onto this coordinate plane, and it's going to look something roughly, like this. It's going to be like that when I graph it. Okay? Maybe. Hopefully. Probably. And the idea, though, is how do I find out some of these things? So what I want to know is what this point is right here. This is what's known as the vertex of the function. And what we're going to have here is this line, right, that we create this axis of symmetry when we graph. Okay? So we're going to try to find two things here, at least just basic pieces of information from this guy. And we're going to figure out what is the vertex. We're going to find the axis of symmetry. And then the vertex. You'll see why. Which we're going to have a minimum or a maximum there. Okay? Now, first things first, let's actually go ahead and tackle this function and figure out a few pieces of information, because let's think about our basic quadratic function, which again was ax squared plus bx plus c, okay? So we got to figure out what a, b, and c are equal to. Well, I'll simply put our a is equal to 2, our b is equal to 8, and our c is equal to -1. The axis of symmetry has the following equation. This is a vertical line. Vertical lines are, of course, going to be equal to just x with no y value, right? So it's going to be some value through the x-axis as a vertical line. So x, the formula is equal to -b over 2 times positive a, or 2 times a. Okay? I'm not really going to discuss how we derive that. And then the other, some other piece of information here is that we have that where c is going to be our y-intercept. Remember when we talked about before that we had this linear term, right? Okay, remember what b was, or just the linear portion, bx plus c. C is that constant. It also serves as the y-intercept the same way it does back in a linear function. So let's do -b over 2a. X is equal to -8 over 2 times 2. Which is going to be equal to -8 over 4, which is going to be equal to -2. That right there is our axis of symmetry, okay? In other words, this line right here is where x is equal to -2, okay? To find our vertex, we're going to plug this value in right here to our original function. So we're going to have 2 times -2 squared plus 8 times -2 minus 1. And this is going to be our vertex. What is this going to equal? Well, it's going to give us 4. And this, again, is the f of -2. This is when we plug -2 into our function. It's going to give us times 4 minus 16 minus 1, or 8 minus 16 minus 1. Okay? 8 minus 16 is -8 minus 1 is equal to -9. So the f of -2 is equal to -9, or in other words, the vertex is equal to, or is the following coordinate, it is -2, -9. all right? That is this, okay? It's that vertex. It's that very bottom point of our function, okay? Let's try doing another one of these. Kind of an older one that we had done before. Let's take same directions where we're going to find the axis of symmetry and vertex of the following, where we have the f of x equal to x squared plus 6x plus 5. Now this is a fun equation to do, right? Because we actually can factor this thing to find solutions. So we actually have enough information to start graphing this thing. I'll show you. I'm going to first find the axis of symmetry. Remember, A, B, and C need to be determined. Well, the coefficient before x squared is just 1, so it's 1x squared. So A is equal to 1, B is equal to 6, and C is equal to 5. Simply put, we're going to put it into our equation, our formula, excuse me, negative B over 2A for x. So this is going to be equal to negative 6 over 2 times 1, which is going to be simply negative 3. There is your axis of symmetry, okay? So what this means is that I'm going to actually go over here and graph this bad boy. Now, I do not know what my quadratic is going to look like, okay? Where it's going to be, right side up, upside down. So this guy is going to be negative 3. 1, 2, 3. On the x-axis, that is going to be our line of symmetry. So what we could do is we could actually plug in values. We could plug in, just for fun, we could plug in 5 values, okay, for this guy. Well, which ones would I use? Well, I'd use 2 to the left of negative 3. I'd go negative 5 and negative 4. I know negative 3 is going to be my axis of symmetry, and I should get the same outcomes if I do negative 2 and negative 1, 2 values to the right of negative 3, okay? And that's going to be easiest for me to do. Just saying, but I'm not going to even go there yet. I'm going to figure out where, is it going to be up here, or is it going to be down here, or where it's going to be to have my vertex. So what I'm going to do for my vertex, I take the f of negative 3, which is negative 3 squared plus 6 times negative 3 plus 5. So that's going to be equal to negative 3 squared is 9 minus 18 plus 5, which is equal to negative 9 plus 5, or is equal to negative 4. So it's saying the point negative 3 comma negative 4 is my vertex. Okay? X equals negative 3 is the axis of symmetry. So I have my 2 pieces of information, 1, 2, 3, 4. Right here is my vertex. That's all I've gotten from this, but I want you to think about the following. Let's continue our graph. There's 2 more things that I want us to actually do, okay? So separately, if we're going to actually graph the entire thing. In addition, let's figure out, we have to do the Y-intercept. That's simple. That's going to be 5. Okay? That's the C value. We already talked about that before. That's this. So that's our Y-intercept. 1, 2, 3, 4, 5. This graph, some way, somehow, is going to make its curve through there. So right now, it looks like it's going to do this, right? That's really the only thing I can think of. But I'm not really sure, is it going to be like a deep curve, or is it going to be like a really like shallow curve, or what's going to be the case? So I need to figure out 2 more things. I'm going to graph, okay, or figure out what are my zeros. Which is going to be points that are on this x-axis. In other words, we're going to make the entire thing equal to 0. Right? Those are x-intercepts. And this takes us back to the last chapter. Now, I'm solving these. Okay? This is 0 is equal to, remember I got a factor. X and x, plus and plus, 2 factors of 5. They're going to have a sum of 6, and that's going to be 5 and 1. So when I go through here and I solve, right, I'm going to have x plus 5 is equal to 0. I'll have x plus 1 is equal to 0. So x is going to be equal to negative 5, and it's going to be equal to negative 1. Those are my two answers there. So I'm going to go back here, okay, and I'm going to actually plug these guys in and plot them on the coordinate plane, okay? So I have negative 1 and negative 5. Well, here's negative 1. Boom, right there. And then we're going to have 1, 2, 3, 4, 5. This is my other point there. And I'm not even worried about how to make this guy, this point that's over on the left, but I'm going to go ahead and get my curve going. So I'm going to have this guy curve through. Oops. I want to make sure my curve makes it through the 2 points it's supposed to. And it's going to do the same thing over here, and that's what my graph would look like roughly. Okay, that's going to be my sketch. And it should be symmetric, right? So it should be identical on this side as it is on this side. Of course, I'm drawing kind of sketchy, so again, it's a sketch, so it's not going to turn out that perfectly. Let's talk about minimum versus maximum, okay? That was something that I discussed earlier. And it's just this. Sometimes we're gonna have two different types of quadratics, the way that they're gonna look in the end, okay? Okay, so what we have here, let's go ahead and we're gonna grab one of these like this, we're gonna have one of these like this. Let's go ahead and do my lines or my curves not so crooked, okay? Trying to make this thing as symmetric as possible. And here I have this being my vertex. A vertex is when we have a minimum, right? It's the bottom of the function. What that means is that when we have in our function the f of x is equal to ax squared plus bx plus c, what this means is that my a is greater than 0. If my a is not, what I get is this guy up here, right? So this is what's known as an apex, not a vertex, but an apex. That apex is a maximum. It's the top of the function, right? The maximum value of it. That's when I have a negative a. So that's really the big determinant for that value of a, okay? Or what a is actually going to do. It's also going to manipulate our function with stretch as well, but not something that we're going to be as concerned about right now. Okay. Last problem that we're going to take a look at today, we're going to see that whether or not the f of x equaling negative 4, I'm sorry, let's not do that. Yeah, let's do that one. I'm sorry, negative 4x squared minus 24x minus 19 has a minimum or a maximum, and then we're going to find that value. So what we need to do, we need to find a vertex or apex, okay? Here, a is equal to negative 4. Here, b is equal to negative 24. And here, c is equal to negative 19. This is totally irrelevant to our problem right now until we actually get back and figure out what is our axis of symmetry, okay? So first, we're going to say that x is equal to negative b over 2a, right? So to get our axis of symmetry, we're going to have a negative 24, right, over 2 times negative 4. So x is going to be equal to 24 over negative 8, which is equal to negative 3. Okay? Now, we're going to plug this guy in. we're actually already at the point where we're finding that value. For the record, can you actually see what this is right now between minimum and max? And I already know the answer is a max, right? And that's because my A is -4. Getting back over to here, right? My A is less than 0, therefore it's going to be a max, okay? So let's figure out what that maximum value is, and that's when we figure out the f of -3, which is -4 times -3 squared, minus 24 times -3, minus 19. So this is going to be a -4 times 9, minus, which is going to be a plus 24 times 3 is 72, minus 19. So we have a -36 plus 72 minus 19. -36 plus 72 is a positive 36, minus 19, and that's going to be 17 for us. So what we know is that we have a max value or an apex that is at the point -3, 17, and that max value itself is 17. Again, -3, that was all it was, is our axis of symmetry. So when we have a vertex, we have an x, y, okay? This guy is the axis of symmetry. This guy is our minimum value. And if it's a apex, it's actually just our max value. That's all, okay? Go ahead and get started in Canvas. Good luck.